Solar panels are great for generating electricity from sunlight. But what happens when the sun goes down? That's where battery banks come in. They store excess energy generated during the day, allowing you to power your home even when the sun isn't shining. Proper battery wiring is crucial for the efficiency and safety of your solar power system. Choosing the right configuration, either series or parallel, depends on your energy needs and the specifications of your batteries and inverter. Understanding the difference between series and parallel wiring is essential for maximizing your solar power system's performance. Series wiring increases voltage, delivering more power, while parallel wiring increases capacity, providing longer runtime. In this comprehensive guide, we'll delve into the intricacies of battery bank wiring for solar power systems. Whether you're a seasoned DIY enthusiast or a curious beginner, this guide will equip you with the knowledge to make informed decisions about your solar setup. Series wiring is like connecting batteries in a chain. The positive terminal of one battery connects to the negative terminal of the next, and so on. This configuration increases the overall voltage of the battery bank. For instance, connecting two 12-volt batteries in series results in a 24-volt system. This higher voltage is often necessary to power larger appliances or meet the input requirements of certain inverters. Series wiring is relatively simple to set up and requires fewer components compared to parallel wiring. However, it's crucial to use batteries with identical voltage and capacity ratings to avoid imbalances and potential damage. Imagine you have two 12-volt batteries, each with a capacity of 100 amp-hours. Connecting them in series creates a 24-volt system with a combined capacity of 100 amp-hours. This configuration doubles the voltage while maintaining the same overall capacity. Advantages of series wiring. Increased voltage. Series wiring increases the overall voltage of the battery bank, suitable for high-voltage appliances and inverters. Cost-effective. Requires fewer components and wiring compared to parallel configurations. Simple installation. Straightforward wiring process, making it easier for DIY enthusiasts. Disadvantages of series wiring. Single point of failure. If one battery fails, the entire system is affected. Capacity remains the same. The overall capacity of the battery bank doesn't increase. Battery matching crucial. Requires using batteries with identical voltage and capacity to prevent imbalances. Parallel wiring focuses on increasing the capacity and amp-hours of your battery bank. In this configuration, all the positive terminals of the batteries are connected, and all the negative terminals are connected. This setup keeps the voltage the same, but increases the overall amp-hour capacity, allowing your system to store more energy and run for extended periods. Imagine connecting those same two 12-volt, 100 amp-hour batteries in parallel. The result is still a 12-volt system, but now with a combined capacity of 200 amp-hours. This configuration is ideal for systems that require longer runtime or power multiple devices simultaneously. Parallel wiring offers redundancy, as the system can continue operating even if one battery fails. However, it demands more wiring and components compared to series wiring. Section 5. Advantages and disadvantages of parallel wiring. First, let's talk about the advantages of parallel wiring. Increased capacity. Parallel wiring extends the runtime of your system by increasing the overall amp-hour capacity. This means, your system can run for a longer period without needing a recharge. Next, redundancy. One of the significant benefits is that the system can continue operating even if one battery fails. So, in a way, it's like a safety net for your power supply. And finally, lower stress on batteries. By distributing the load evenly across all batteries, parallel wiring can potentially extend their lifespan. This balanced load means each battery doesn't have to work as hard, which is definitely a plus. Now let's move on to the disadvantages of parallel wiring. Voltage remains the same. This configuration is not suitable for high-voltage appliances or inverters that require higher voltage input. So, if you need a higher voltage, parallel wiring might not be the best choice. More complex wiring. Parallel wiring requires more wiring and components compared to series configurations. This added complexity can make the setup a bit more challenging. And lastly, higher installation cost. The increased complexity and additional components can lead to higher installation costs. So you might want to consider this when planning your setup. Section 6. Step-by-step guide. Wiring batteries in series. Before you begin any electrical work, ensure you have the necessary safety gear, including gloves and safety glasses. Disconnect all power sources to the batteries before handling any wires. 1. Gather your materials. You will need your batteries, appropriately sized battery cables, wire connectors, and a wrench. 2. Connect the batteries. Connect the positive terminal of the first battery to the negative terminal of the second battery. 3. Continue connecting. If you have more batteries, connect the positive terminal of the second battery to the negative terminal of the third, and so on. 4. Final connections. The remaining positive and negative terminals will be used to connect to your inverter or charge controller. Section 7. Step-by-step guide. Wiring batteries in parallel. As with series wiring, safety is paramount. Disconnect all power sources before starting and use appropriate safety gear. 1. Prepare your materials. Gather your batteries, appropriately sized battery cables, wire connectors, and a wrench. 2. Connect the positives. Connect all the positive terminals of the batteries together using battery cables and connectors. 3. Connect the negatives. Similarly, connect all the negative terminals of the batteries together. 4. Final connections. The connected positive and negative terminals will be used to connect to your system. Section 8. Choosing the right configuration for your needs. Choosing between series and parallel wiring depends on your specific energy requirements and the specifications of your inverter. If you need to increase voltage to meet the requirements of your inverter or power high-voltage appliances, series wiring is the way to go. However, if your priority is longer runtime and increased capacity, parallel wiring is the better option. Carefully consider your energy consumption needs, the voltage requirements of your system, and the desired runtime to make an informed decision. Consulting with a qualified electrician or solar installer is always recommended for complex installations or if you're unsure about the best approach. Section 9. Conclusion. Powering your future with solar energy. Mastering battery bank wiring is essential for harnessing the full potential of your solar power system. Whether you choose series or parallel wiring, understanding the advantages and disadvantages of each configuration empowers you to make informed decisions. Remember to prioritize safety, use appropriate components and wiring, and consult with professionals when needed. With the right knowledge and careful planning, you can enjoy the benefits of clean, renewable energy for years to come.